Hello, I'm Brad Beebe. I'm the General Manager for Amazon Neptune here at Amazon Web Services. More than 6 years ago, I joined AWS to launch a managed graph database service. And today, I'm very excited to share with you getting started with Neptune Serverless. We're going to cover 3 things. I'm going to give you a quick introduction to graphs at Neptune and some of the use cases. We're going to go over what Neptune Serverless does. And then I'm going to show you how to get started with Neptune Serverless. Let's jump right in. Graphs are awesome. The reason graphs are awesome is that they allow you to use the relationships in your data to gain new insights. And there's 4 things that I'd like you to take away today about graphs. The first is that graphs are a data structure in which the relationships are a first-class part, and so they allow you to model the relationships directly. Graph applications explore the patterns and connections of these relationships in your data. As you traverse a graph and you go between nodes and follow these relationships, it's very hard to predict which node you're going to reach next. And this means that graph applications are often dominated by random data access patterns. So the same kinds of techniques that you use to optimize for highly structured data, like relational databases, don't always work well for graphs. And so if you want to do generalized graph processing, you should look at a database that's purpose-built for graphs. Amazon Neptune is AWS's managed graph database service. It's optimized to store and query billions of relationships interactively with millisecond latency. And it provides you the most choice of open source and open standard graph query languages with support for OpenCipher, Apache Tinkerpop Gremlin, RDF and Sparkle. And now Amazon Neptune is serverless and global too. Every day, thousands of customers use Neptune and create tens of thousands of Neptune instances to power a wide variety of use cases. There's really 4 major areas where we see significant customer use case traction. Knowledge graphs use relationships between information to help drive better information retrieval. Customers like Siemens are powering their knowledge graphs using Neptune, building things like digital twins for their IoT services. Identity graphs use relationships between customers or devices or other identity types records to create 360 views of customers for ad tech and martech kinds of use cases for identity resolution. Customers like Cox Automotive are powering their identity graphs with Neptune to allow them to track the digital journey as customers move across their various properties. Fraud is only limited by the ingenuity of those who commit it. By using graphs, you can take advantage of the relationships around different transactions or different activities to detect fraud in new and different ways. Customers like Games 24/7 are using graphs around the participants in their online games to detect different kinds of fraud. Security is a classic graph use case, and the relationships between IT resources can help you understand how to secure and protect them. Customers like Wiz are building security graphs with Neptune to help detect and identify which risks are most critical for you to prioritize. One of the things that we consistently heard from our customers is that they loved graphs and the power of the relationships, but that managing and predicting the capacity for their graph databases was hard. Amazon Neptune Serverless is the world's first serverless graph database that automatically scales capacity up and down based on the graph workload that you provide. This allows you to save up to 90% of your database costs versus provisioning for peak capacity. With Neptune Serverless, you get all of the same features for query, high availability, scalability that you get with provisioned Neptune, but we've added something new. We've added something that's called a DB serverless instance. You can create these DB serverless instances and add them to your cluster. They can be writers, they can be readers. You can combine serverless and non-serverless instances. Serverless can even be part of your Neptune global database clusters. The fundamental unit of capacity in Neptune Serverless is something that's called a Neptune Capacity Unit, or NCU. One NCU is equal to 2 gigabytes of RAM and proportionate amounts of CPU and network bandwidth. When you create a Neptune Serverless instance and attach it to a cluster, you specify both a minimum NCU level, which is your starting point, and a maximum NCU level, which serves as a cost control. It's the maximum that will scale on your behalf. As you issue queries or loads to your Neptune Serverless instances, we can see the CPU utilization and the memory utilization increasing. As that increases, Neptune Serverless automatically allocates more capacity in terms of NCUs to be able to meet the demands of your workload, scaling up in a predictable, linear fashion that happens faster as your capacity gets larger, and then scaling down again when your workload stops. Let's look at an actual customer example. These are some serverless database capacity CloudWatch metrics for a customer based in EU West 1. And if you can see that if we start on the left-hand side, that you can see that their cluster is provisioned at the minimum NCU pieces. Now, the first thing we notice is that there's an initial scale up when they've applied workload to their cluster. They didn't scale up all the way, but partially. We later see that they've scaled all the way to their maximum NCU capacity. There's a brief scale down, and then when the workload is finished, they scale back down to their minimum. And if you look across the right-hand side, you can see that over time, this scaling behavior continues as they apply the workload. And this is really where the opportunity for cost savings versus peak provisioning is with Neptune Serverless. This is the same customer's cluster, but rather than showing a customer-facing view, this is our internal view of that cluster. Each of the different colored line series represents part of the decision-making that goes inside of Neptune Serverless. So it's looking at the CPU utilization, the memory utilization, the network bandwidth. And we use all of these factors to help us decide when and how to scale so we can scale quickly and responsively when you add workload to your cluster. So when would serverless not be a good fit? The maximum serverless capacity today is 128 NCUs. This is approximately equivalent to an R6G 8x large. If you already have a Neptune workload or a Neptune cluster that's using a larger instance type, often because you have a memory-intensive workload, then Neptune Serverless may not be a good fit. Also, if you have a highly predictable steady-state workload that doesn't vary, then you may not need the system to be able to change for you, and you may be better off looking at a provisioned piece. We're constantly working on Neptune Serverless with things like supporting lower capacity units. Today, the minimum is 2.5, and we'd love to hear your feedback. So now let's switch over to take a look at getting started with creating a serverless graph database. So I've gone to my AWS console in US West 2, and I've gone to Neptune. And the first thing we're going to do is show how to create a Neptune serverless database if you haven't created one before. So the first thing that I'm going to do is I'm going to click Launch Amazon Neptune. I go into this Create Database dialog, and I'm immediately presented with a choice. The engine type is provisioned or serverless. Now, with provision selected, I'm going to just show you the different Neptune versions. So these are the different Neptune engine versions that you can choose with provisioned. Now, to create a serverless one, I simply select the serverless radio button here, and it automatically picks the right version for Neptune for serverless. And then I need to choose a cluster identifier. So I'm going to call this one Neptune Serverless 2. And I choose the capacity. So remember we talked about the NCUs and how they specify the minimum and maximum capacity. I'm going to start this one with 4, and I'm going to set the maximum to 64 NCUs. I have a choice to create a multiple availability zone deployment. So simply by leaving this selected, I can create a highly available serverless graph database cluster. And I have other choices for VPCs, the Neptune notebooks, which are a way to help you get started visually with your graph applications, and other configuration options. These are the same features as you get with Neptune Provision. So if you're already used to using encryption at rest with customer managed keys like KMS or Neptune audit logging, those features are all available. And to get started, I simply click Create Database. And this is going to go into the serverless cluster creation workflow. And what you'll see at the end is that the serverless has been created. Now, that's not the only scenario that I have. So I've gone ahead and created a couple of other clusters already. So here I have a provisioned Neptune cluster. And what I would like to do is I want to try out Neptune Serverless. So what I can do here is I can select the cluster and select an instance in the cluster, and then I can choose to modify that instance. And what this will do is it will change that from a provisioned Neptune instance into a serverless one. And you can see I can simply do that by selecting serverless here. Then I can specify the capacity settings. I get the same options here for modifying the cluster. And once I do that, I can choose whether I want to modify it in the next maintenance window or apply immediately. I'm going to choose apply immediately here. It gives me a warning that this may cause some downtime if the outage requires an instance restart. And then I'll choose to modify the database instance. So that's what I've done to take my provisioned instance and make it my provisioned cluster and make it serverless. Now there's one other case that I wanted to show to you today. Suppose I had a provisioned Neptune cluster that was on an earlier engine version. Well, I would have to add one more step. And so the step I have to do is to update that cluster to use the engine version that supports serverless, which I can do by selecting the cluster and clicking Modify in the console. And then I choose a database engine version that supports serverless. And by going through this and updating the cluster, I'm then able to put the cluster on an engine version that supports serverless, at which point I'll be able to add those instances just like I've done for the other ones. So now that you've created your serverless graph database, either from scratch, from a new cluster, or by adding a serverless instance to one of your existing clusters, I would encourage you to check out something like the AWS Graph Explorer. This provides a low-code graph visualization tool that you can use to browse your serverless graph database. And it's available in open source under an Apache 2 license. So as a quick recap today, graphs are awesome, and thousands of customers use Neptune for use cases like knowledge graphs, identity graphs, fraud graphs, and security. Neptune Serverless automatically scales capacity for your graph applications so you don't have to. And you can create new serverless graph databases or add instances with a few clicks in the AWS console. I'd like to thank you for your time, and I'd love to hear from you about Neptune Serverless or graph applications in general. Thank you.